This video is to help you with investigation 5. I'm using the homework assignment from week 10A to be the example for this. So this is the example where the managers are looking at resumes and deciding who they should promote or personnel files, and they are given the same identical information, except some of them are male candidates and some of them are female candidates. And this is back in 1972, and they're trying to see if male candidates are more likely to get promoted. So you can see the results, and there's a red box here because I want to remind you that you want to look for the explanatory variable and then read across that row or down that column, depending how your table is set up. So this case is different than the one that we saw in class with the dolphins in that it reads across instead of down, because the explanatory variable is whether you're male or female, and the response variable is whether you get promoted or not. So we have 14 women who did get promoted, and we're defining that as a success. In this version, you could define any of these four numbers as a success, whatever interested you the most. So I'm not going to go through all the details of this. I want to work on the applet only. And what I want to point out is that as we go through the solutions down toward the bottom of page 2, I have another table where I rearranged it so that male and female are now in columns and promoted and not promoted are in rows. And I did this because the applet only accepts information in this way. So we're going to take this information and put it in our applet. And our applet is the two-way tables applet. And it has a bunch of items you can choose here, but it doesn't have this one about men and women's promotions. So just click 2 by 2. And if you want, you can name the columns and rows. If you do that, make sure you do not put a space in there. So I'm just going to write not pro right there. And then the data that we want to put in is 21, 14, 3, 10. Notice it does the addition for you. And then you tell it use table. And it gives you this bar graph telling you, you can see a higher amount of men were promoted than women. The ratio, there's a tiny little bit of men who weren't promoted and more women who weren't promoted. So I told you a success was the female being 14, but the applet is actually going to read the male 21 as being a success if you were to look at group A successes and then click this little shuffle option. We could put in 1,000 shuffles, and it's going to be reading, it's going to be working with that idea that that's about how many men got promoted. And we actually we defined our success differently, but that doesn't really matter, because what we're going to look at, instead of successes, counting the successes, we're going to look at the difference in the proportion of successes. And notice if I change it down here, it changes up here. So I'm going to do that again. And now you can see the graph is centered roughly around 0. There would be a 0 in here. And the applet also tells us what the difference is. So we don't have to figure out the conditional proportions and subtract them. It will just tell us. So we can take that number and put 0.292 over here and hit count. And it shows us where our line would be in red, where 0.292 is. And this applet, instead of putting the p-value at the top of the red line, it puts it in red and calls it the count. So the count is 52 over 2,000, which our p-value then is 0.026. So that's the value we're going to take away from this. Also, when we do the difference in proportions, we can use this 95% confidence interval option. It will always give the option in terms of difference of proportions. So if I select group A successes again, you can see it is not, the numbers have not changed to move to fit with these 14, 16, 18. So it's only working with difference in proportions. So that's the confidence interval. And we already have our p-value. Put it back, and that's about it.